hello viewers, a glorious and warm good afternoon to everyone. It's my pleasure to introduce myself, and I am Nandini from studying in first MPC from TSWREIS Chitkal COE. Friends, before we begin, let's analyze a picture. Friends, here you can see a picture. What is the picture about? Here the picture is about a race is going on for small kids, isn't it? So friends, what else can you observe? There you can also see some elderly people stood beside them and they are cheering up the children with their energetic claps, right? So friends, is there any relation between these two actions, or is the action running is influenced by any other action? Just think. So here, of course, definitely this action running is influenced on other action, and definitely there is a relation between these two actions. Let's see what's that. Here, if I put these words in the language of chemistry, if we compare these actions with a reaction, there the cheering up of the people, they are acting as a catalyst. What's this word catalyst mean actually? What are the significance of this catalyst and properties of this catalyst? So, to know the answers for these questions, let's proceed. So friends, the aim of my presentation today is to know what is a catalyst and the process catalysis, applications of catalysis, homogeneous and heterogeneous catalysis, activity of a catalyst, selectivity of a catalyst, shape selective catalysis by zeolites, and last but not least, applications of selectivity. Now friends, let us turn to the issue of catalyst. What does this catalyst mean? A substance which increases the rate of reaction is known as a catalyst. What does it mean? A substance which increases the rate of reaction is known as a catalyst. Friends, you can see on the slide a graph, right? Here you can see the two curved line, which is one of the curved line is colored in blue, right? It represents uncatalyzed reaction, and the other curved line, which is colored in red, it represents catalyzed reaction. Friends, what is the difference between these two graphs? These two curved lines? Here you can see the activation energy is increases in red colored curve, which is catalyzed reaction, and the activation energy is less in blue colored curve, which is uncatalyzed reaction. So friends, to know more, let's proceed. In chemistry, we have n number of reactions, isn't it? Yes. So friends, for better clarity, let me take an example. Here, when potassium chlorate is strongly heated at 653 to 873 Kelvin, when it decomposes slowly and gives potassium chloride and oxygen. The same reaction takes place at an accelerated rate at lower temperature at 453 to 673 Kelvin when manganese dioxide is added to the reaction. Friends, what is the difference between these two things? What did you notice? Here, you can notice that Here manganese dioxide is not consumed in the reaction, but it increased the rate of reaction, isn't it? And also you can see that here the mass and composition of this manganese dioxide remains same as at the initial stage. Okay friends, it means that, do you know, in 1935, one of the famous scientists, Berzelius, he recognized these substances as a new chemical force and later he called them as a catalyst. What's that? Catalyst. Now friends, can you say here in the above reaction which we have discussed, which substance acted as a catalyst? Can you? Yeah, that is manganese dioxide acted as a catalyst. In the same way which we have discussed earlier in the picture which we have analyzed, there who acted as a catalyst? Yeah, they are the elderly people who cheered up the children, they acted as a catalyst. It means that did they participate in the race? No, not exactly. Then they just enhanced the children to be the first in the race, isn't it? Yes, it means they boosted up the children to be first in the race, right? So friends, that's why cheer girls are introduced in famous matches like IPL, Pro Kabaddi and Khel Kabaddi. So friends, now let us move a bit further. So friends, these complete catalysis, this complete process is known as catalysis. What's that? Catalysis. Do you know friends, where do we use this process called catalysis? In our daily life? Yes, we use this process catalysis in Haber process in the manufacturing of ammonia. What's that? Ammonia. Where do we use this ammonia? This ammonia is used by farmers to get better yield in their agriculture purpose, right? So friends, the reaction goes like this. When nitrogen is reacted with hydrogen in the presence of catalyst iron to give ammonia. So this ammonia is useful for the fertilizers by the farmers. So friends, secondly, this process is used in the contact process to manufacture sulfuric acid, which is used to make the detergents and fertilizers in the presence of catalyst vanadium pentoxide. This process is also used in the contact process. Now, thirdly, this process is also used in catalytic converters in vehicles. What's that? Catalytic converters in vehicles. Here friends, I hope that you are aware about the toxic gases which are released by the vehicles, aren't you? Okay, what are those toxic gases? For example, methane, many hydrocarbons, CO2 gas, etc. and etc. So friends, I think you are aware about how harmful they are, right? They causes such a danger condition to the ozone layer, which is very harmful to the people, which causes skin diseases, right? So friends, here comes catalytic converters in vehicles. It plays a key role in converting these toxic exhaust gases into harmless products. So far friends, we have discussed about what is a catalyst and the process called catalysis and the applications of catalysis in our daily life. Where do we use this process catalysis in our daily life? Yeah, one is Haber process, contact process, and in catalytic converters in vehicles, right? Now friends, let us move a bit further. So friends, these process catalysis is further broadly classified into two types. How many types? Two types. What are they? One is homogeneous catalysis and other is heterogeneous catalysis, right? Now let us have a closer look at homogeneous catalysis. Okay, now let's see homogeneous catalysis. Friends, are you familiar with the word homo? What does it mean? Homo, it means same or similar, right? Now we can define homogeneous catalysis as in a catalytic reaction, the phase of reactants and the phase of catalyst should be same. For example, let me make it clear. Here you have reactants and catalyst, right? The phase of these reactants should be same and also catalyst. For example, here if the reactants phase is in gaseous phase, then the phase of catalyst should be also in gaseous phase. If it is in liquid phase, it should be also in liquid phase. I mean, they both states should be same. For example, for better understanding, when sulfur dioxide is reacted with oxygen in the presence of catalyst nitric oxide to give sulfur trioxide. Here friends, what are the reactants acting in this reaction? They are sulfur dioxide and oxygen, isn't it? What is the state of that? What is the phase of that? It is, they are in gaseous form, right? Then what about the catalyst nitric oxide? What is the phase of that? It is also in gaseous phase, isn't it? So, by this you can conclude that the phase of reactants and the phase of catalyst should be same. From this, the phase of reactants is in gaseous form and the phase of catalyst is also in gaseous form. So, this process is known as homogeneous catalysis. What's that? Homogeneous catalysis. Now, you may define heterogeneous catalysis. Let us now see heterogeneous catalysis. Here, in a catalytic reaction, we have reactants, catalyst and also products. Here, the phase of reactants and the phase of catalyst should be different, right? It means that if the phase of reactants is in solid phase, the phase of catalyst should be different. Suppose it should be in liquid, right? If the phase of reactants is in gaseous phase, the catalyst phase should be in solid phase, right? For example, let me make it clear. Here, which we have discussed earlier in the Haber process, in the manufacturing of ammonia, there the reaction goes like this. When nitrogen is reacted with hydrogen in the presence of catalyst iron, it gave ammonia. Here, what are the reactants? The reactants are nitrogen and hydrogen. What is the phase of that? They are in gaseous form, isn't it? Then, what about the catalyst? Iron? It is in solid phase. So, here the state of reactants is in gaseous form and the state of catalyst is in solid state, right? So, the phases of these two reactants and catalyst is different. This is known as heterogeneous catalysis, right? So far, friends, we have discussed about catalyst, the process catalysis and applications of catalysis, and this process catalysis is broadly divided into two types. One is homogeneous and heterogeneous. Homogeneous, it means the phase of reactants and the phase of catalyst should be same. And what about heterogeneous? the phase of catalyst and the phase of reactants should be different. Now, hope you have got a clarity about homogeneous catalysis and heterogeneous catalysis. Do you know, friends, most of the heterogeneous catalysts are solid in nature. So friends, here let us move a bit further. These solid catalysts, there are two important features of solid catalyst. What are they? One is activity of a solid catalyst and other is selectivity feature of a solid catalyst. Now let us have a closer look at activity of a catalyst. Friends, the activity of a catalyst is further defined as the ability of a catalyst in increasing the rate of reaction is known as its activity, right? So friends, for example, here in the periodic table, the catalytic activity increases in group 5 to group 11 metals with maximum activity being shown by the group 7 to group 8 metals of the periodic table. So, chemically, if we see an example, here on this slide you can see an example. What's that? Here hydrogen peroxide is reacted in the presence of catalyst yeast to give water, oxygen and also heat, right? So friends, here from this, the yeast, it's a catalyst, it increases, the ability of that catalyst increases to increase the rate of reaction. So friends, hope you have got a clarity about activity of a catalyst. Do you know most of these activity of catalyst is dependent upon chemisorption. What's that? Chemisorption. Friends, you should also notice that the adsorption of these reactants should be reasonably strong so that it will be reactive. It will be reactive more. Okay? So friends, now this directly leads to my next topic, selectivity feature of a solid catalyst. So friends, I hope that you often visit many libraries, big shopping malls and supermarkets in our daily life, aren't you? Okay friends, there are n number of books are displayed, isn't it? Friends, do we pick all the products which are displayed? No, not exactly. So what do we do? When do we go? If we go there, what do? We pick the product which are displayed there based on our taste and needs, right? So in the same way, let me relate this to the selectivity feature of a solid catalyst. It is further defined as the selectivity of a catalyst is its ability to direct a reaction to form specific products. What's that? The ability of a catalyst to direct in a reaction to form specific products. Okay, it's defined as selectivity feature of a solid catalyst. For example, friends, if we look chemically, here on this slide you can observe three reactions, right? Firstly, here the reactants of these three reactions are same. What are those? When carbon monoxide is reacted with hydrogen in the presence of different catalysts to give different products, right? First, in the first reaction, you can see when carbon monoxide is reacted with hydrogen in the presence of catalyst nickel, it forms methane and water. So, in the second reaction, the same reactants, those are carbon monoxide and hydrogen. They are reacting in the presence of catalyst copper and zinc oxide to give methyl alcohol, right? And in the third reaction, the same reactants are reacting in the presence of catalyst copper to give formaldehyde. So friends, from this we can conclude that based on the products we select catalyst, isn't it? So here these are directing the rate of reaction to proceed in the path to give specific products, right? So friends, here the selectivity feature of in this process, most of the solid catalysts are dependent upon the shape and size of the catalyst. Before this, you should also notice that if a substance is chosen as a catalyst in one reaction, it should be acted in that reaction only. It shouldn't be acted in another reaction. It may fail to catalyze the reaction. So now let us discuss the solid nature of this catalyst. Here the solid catalyst is dependent upon the size and shape of the reactants. The catalytic reaction which depends upon the size and shape of the reactants, porous structure and also product molecules, it is known as shape selective catalysis. What's that? Shape selective catalysis. So friends, the best example for this is zeolite catalyst. Do you know where do we use these zeolites in our daily life? We use these zeolites in petrochemical industries. Do you know these zeolites are in the shape of honeycomb-like structure? Is this honey? How honeybee prepares its own honey, dear friends? Do you know? It will be very tasty, no? So here honeybee sucks the nectar from the flower and it exactly inserts into the cells of the honeycomb. Am I correct? Okay. So here the same process takes place in zeolites. The catalytic reaction which takes place in zeolites, they are dependent upon the porous structure, I mean pores and cavities, and also the shape and size of the reactants and also product molecules of the zeolites. This is known as zeolites, right? The important catalyst which is used in the petrochemical industries, that is ZSM5 catalyst, zeolite Saucony Mobile 5 catalyst. So friends, where do we use this catalyst in our daily life in petrochemical industries? What is the use of this catalyst ZSM5, that is zeolite Saucony Mobile 5? Here it converts this catalyst directly into, it converts alcohols directly into gasoline, right? Hope you have understood about what is activity of a solid catalyst, what is selectivity feature of solid catalyst, and also the shape selective catalysis, right friends? Now do you know friends, I've got you an interesting news. What's that? Let's see. Hope you are aware about the pollution which is caused in the capital city of India, that is Delhi, and Beijing, the capital city of China. So friends, it's a recent war scenario which took place in our country, not only in our country, overall the world, isn't it? So friends, how harmful the situation is at the time. So friends, can you imagine this world with this pollution? What is the solution for this? How long these Delhiites would afford to live in these gas chambers? Is it possible? Is this the world we want to live in? No, not exactly. Then what's the solution? Isn't there any solution for this? Is this the world we want to live in? Just think a second. So, here scientists are really investigating a lot to find the solutions for such kind of really glorious and scary situations. So, one of the recent breakthrough innovation is the scientist from US, United States Department of Energy, that is Argonne National Laboratory, he and team, they have used sunlight and a catalyst largely made of copper to transform carbon dioxide to methanol. So friends, it is the best example for our today's topic, selectivity. When they have selected titanium dioxide as a catalyst, they have got various mishmash products like from aldehydes to methane. It is also harmful gas. But when they have switched to the catalyst copper, they have got a useful product, that is methanol, a liquid fuel. From this, we can conclude that the catalyst is based on it is very selective in nature, right friends? It may be geometrically or chemically. So friends, here finally I would like to highlight a key issue that with such innovations, the days are not so far, because we might see a clean and clear Delhi. Our future will be bright and perspective. So friends, finally, ultimately I would like to say that be a part of solution but not a part of pollution. To be fantastic, don't litter this world with plastic. Hope you have got a clarity, and to summarize, today we have discussed about what is a catalyst, catalysis and the applications of catalysis in our daily life, and homogeneous and heterogeneous catalysis, activity of a catalyst and selectivity of a catalyst, shape selective catalysis by zeolites, and last but not least, we also discussed the applications of selectivity. Right friends? Hope you have got a clarity. Now finally, I would like to conclude by thanking our beloved Secretary Sir for giving this great opportunity and for investigating these programs, and also thank to TSAT network and TSWREIS, the government of Telangana, for implementing such kind of programs. Today I am here because I shall never fear the unknown. By this thought, I am really very happy to stand in front of you. Thank you friends for giving this great opportunity. Thank you one and all. Thank you.
అంజనీ మైక్ తీసుకురాపా, నేను అందుకే ప్రాబ్లమ్ వస్తుంది. తీసుకురాపా. నువ్వు మస్తు చెప్తావు పో